Hi, welcome to Angles and Acid. So in this episode we are going to look at convection as a form of heat transfer. To do convection, you will need the following. You need some mobile particles, so this will be things like liquids and gases. If you don't have any mobile particles, then you can't do convection. Here we have some chickpeas in a beaker of water, and we're going to bring it to the boil. By heating it up, we can follow the convection currents in the beaker or the water by watching the movements of the chickpeas. The temperature of the bottom of the beaker, at the bottom of the water, is much warmer than the water in the top region of the beaker. The particles at the bottom, they gain this extra energy, this extra kinetic energy, and so the particles move further apart. When the particles move further apart, you create a low pressure zone, or a lower density. So with the water, it becomes less dense at the bottom because it's warmer. And so we know that things that are less dense will tend to rise to the surface. When it rises to the surface, it carries those chickpeas up with it to kind of demonstrate to us what is happening. So this picture here is from Wikipedia, some illustrators called Orion and Construct, 2007. They're basically illustrating the same thing that we saw in the chickpea beaker. The heat is being applied at the bottom of the beaker, and so everything that is closest to that side of the beaker is going to be very much warmer than the top. When the chickpeas and the hot water rises to the top because it's less dense, it is then exposed to the cooler atmosphere because the air around at the top is much cooler than the air below, which was made out of the hot Bunsen burner. So that means that it can give away some of that heat energy to the cooler air particles above the surface of the water. When it does this, it loses its heat energy. It loses this movement or this kinetic energy that each particle has, and so they kind of come closer together because they're pushing each other apart less. So now that they are more dense, they then sink down to the bottom of the beaker and they go the process all over again. I hope this helps. This was convection. See you later. Bye.
Whenever an object is heated, energy is transferred to its thermal energy store, and its temperature increases. The process of heating, though, can take place in three different ways, depending on the medium involved. For solids, heat is transferred by conduction. In fluids, it's via convection, and to get through empty space, heat has to be transferred in the form of radiation. Let's start with conduction. The key idea behind conduction is that vibrating particles transfer energy to neighboring particles. To understand how this works, let's imagine that you were heating one end of a piece of metal with a Bunsen burner. And imagine the piece of metal as a series of particles. As the end of the metal is heated, energy is transferred to the metal, or more specifically, is transferred to the kinetic energy store of the particles at that end. This causes the particles to vibrate faster, and so they collide with their neighboring particles more often, and with more energy. As the collisions transfer kinetic energy, the neighbours will also vibrate faster, and collide more with their neighbours. And as this process repeats, energy is passed along the piece of metal, until in the end, the heat is spread out evenly, and it will be pretty much the same temperature everywhere. Now, the reason that conduction occurs mainly in solids is because the particles in a solid are held together really closely, which means that there's lots of collisions that pass on the energy. Whereas in liquids and gases, the particles are all further apart, and so they don't collide as much. Exactly how well objects transfer energy by conduction is known as their thermal conductivity. Metals have a high thermal conductivity and transfer heat energy rapidly, whereas plastics have a low thermal conductivity, which is why we use them as insulators. And pretty much all fluids have a low thermal conductivity. Convection, on the other hand, occurs mainly in fluids. And remember, fluids can refer to anything that can flow, so both liquids and gases. Because the particles in fluids aren't fixed, once they're heated and they gain kinetic energy, they all move around faster. By the process of random diffusion, this will cause these more energetic particles to move away from the warmer region towards the cooler region. And overall, this means that the higher energy particles in the warmer region are a lot more spread out than those in the cooler region. So effectively, the fluid in the warmer region actually expands as it heats up, and so becomes less dense than the cooler fluid. To understand how this works in real life, let's imagine that we had a container of fluid, so that could be either liquid or gas. As we heat the container, the following things would happen. First, the particles near the heat source would gain kinetic energy and spread out, becoming less dense. Because they're less dense, these particles rise above the colder, less dense particles above them. And at the same time, these cooler particles sink down and take their place. Whilst this is happening though, the hot particles would lose their energy and cool down, and the cool particles now at the bottom would heat up. Because of this, the cycle would keep on repeating for as long as the fluid was being heated, and we call this cycle a convection current. We actually see these convection currents all over the place, from oceans to inside buildings, where radiators warm the nearby air and set off the cycle. On the other hand, to reduce convection, we need to stop the free flow of fluids, which is all we're doing when we sleep under a blanket at night, which is stopping the warm air from escaping. What conduction and convection have in common is that they both involve particles gaining kinetic energy. It's just that in conduction, only the energy is transferred between the different particles, whereas in convection, the particles themselves move. However, heat energy can also be transferred without particles, which means it could travel through a vacuum. This happens when energy is transferred by radiation, and specifically when the energy is carried by infrared waves. All objects constantly absorb and emit radiation, and in reality they do both at the same time. Importantly, the hotter the object is, the more radiation it emits. This is why it feels hot to put your hand over a barbecue, even if you're not touching it. The very hot metal and coal is emitting infrared radiation, which is absorbed by your hand. We take a closer look at infrared radiation when we cover the electromagnetic spectrum. Anyway, that's all for today. So hope you enjoyed this video, and we'll see you next time.